Okay. Go. Let's solve some greedy problem first. I really want to improve my greedy logic. So jump game, gas station, candy, and gas station along a circular route. Amount of gas. You have a car with unlimited gas tank and cost itne of gas to travel from ith to its next. You begin the journey with an empty tank, one of the gas stations. Starting, you can travel around the circuit once in a clockwise direction. Otherwise, -1. If there exists a solution, it is guaranteed to be unique. What? If I can, travel to station 4, tank is 8. Four -1. Then you add 5. 8765. Wait. Okay. -1 if it's not possible. Want to start from here? No, because the cost is 3. And it costs this much fuel to travel from one to another station. And this will subtract. This will add up. So three, 7, 6. Talk about suffix. And this is circular. what I can do. Um, but if I start from 3, I'll start from 4, right? Wait, what will be my cost? Um, I will be summing up all of this 4 by 4, 5, 1, 2, 3, right? And also subtracting 10 to the power 5. Okay. So I need, so these values should not go negative. I should have gas greater than or equal to the cost. Okay. I can store prefix sum. Let's try this out. Mm, so like at first index, cost should be equal to or greater than gas. Then only I can move forward. So it could either be 4 or 5. Um, and currently it's 4, then it will move, it will become 3, then it will become plus 5. So it will go like 4 minus 1 plus 5 minus 2, and it should not go negative at any point in time. It can go to 0 but not negative. So maybe I can do something. I want to maximize my tank. Yeah. The goal is to maximize tank. Um, what's the difference? This is -2. And it's also -2. It's also -2. 4 minus 1 is 3 and 5 minus 2 is also 3. So I can start at 3. I will have 6 at the end. Then I can do -2, -2, -2. Okay. So I need to see if this difference is negative. I just can't do it. Right? Yeah. Let's look at the difference. Okay. And difference is going to be gas minus cost. If difference is okay. Wait, this is not true. I need to see running difference. Can I go for prefix and suffix? So what is prefix? Here prefix is -6, suffix is also 6. So if this is equal, can also be greater. Is -1. Wait, it is guaranteed that there can only be one solution. What does that mean? If everything is positive, all there are solutions, right? What does it mean to have only one single solution? I believe prefix and suffix is going to be equal. There is only one solution, right? Um, hmm. So, net sum, if this is positive, then also I can say that I got the answer. Because you can start from here, right? But what if it's going negative here? Mm, can I do it with running sum? But what if I have something like and it is going to be positive, but this is wrong. Look, and children standing in a line assigned a rating value given in the integer array ratings. Candies to these children, at least one candy. If rating is higher, then he should have more candies than the neighbors. Zero, one, two. I can give him one candy, two and two, right? How I am going to do that? With the lowest rating, one to one. Okay. We'll start with one. If neighbor is bigger, I'll give him two. Yeah. What if neighbor is smaller? Should I start with can I binary search minimum candies, but how will I distribute? This is there are two peaks and one down. So in that scenario, I can do like 1 2 2, right? I need to see how many peaks are there, right? Hmm. Let me see. Wait, whatever I have. I can probably do that. Um, then 2 is greater, so it is going to be 2. And you have something that is same. It can have like a single candy. I can do that. Okay. I will start with 1 and I will do just whatever is the previous one. Then I will see what is the minimum. And I will make it 1. I'll sum up everything. Will this work? Let's give 1 candy to everybody. Okay. Now let's start checking. Okay. Um if it's less, I should do -1. Okay. Let's start with 1. Now what I can do is I can check if ratings of I -1, if current is greater. Okay. So only greater is the bound, right? If this is greater, then candy of I is going to be candy of I -1 plus 1 because this is greater. So else I can do -1. Can I check? Um Now I just need to see what is the most negative number. To turn the fan off. Okay. I got it. Let's do some test cases. 0, this will be -1. This is greater, so this is going to be 0. Smaller, this will be -1. 0. Then we have even greater 5, greater 6. So we'll do +2. 1, 2. 1, 2, 3, 5. This is the only way. Then it should have greater. It should have greater. Okay. Why is it 5? I have 4. Okay. I think it's correct. I have what I want. I want minimum element in this candy. Okay. Once I have this, I will take delta will be absolute of this mini +1, right? This is -2. If minimum is 0, let's say, I should add 1 to every single one of them. It's fine. Let's track. Let's take answer is 0. Let's loop. Okay. Now answer plus equals to whatever we have in the candy plus whatever is delta, and we can return answer. My bad. I think this is good. No? 1 3 2 to 1. What? Seven should be the answer. If this is the same, what should I do? I need to check in both directions. I'm only checking in a single direction. Yeah. Yup. Switch job. You need DSA in like most of the companies. They usually ask in their first or second round. Right, so there is no other option. And I believe it is also like a best way to judge somebody whether he can work. Very bad at greedy proofs. This is not optimal. I need to go probably in both of the directions, and I will try to reduce as much as I can. Right? Maybe show description of the problem. There we go. So this I have to do. Okay. Else I'm subtracting. It should be above. Fine. And it should be down. It is also fine. But here I'm going down as well. And this is a problem. Let me try something at least. I will only check for the condition, okay? I will only check for this. Okay? If current is greater, then just do whatever you have previously, just do a +1. Okay? Skip everything. So 1 3 2 2 1. This is less. I don't give a fuck. This is less. I don't give a fuck. Then I need to do it in reverse. I have 1 1 1 2 1. This should increase. Okay, I think this is going to work. Start with n minus 2. Okay. Now, if I plus 1 is greater, if current is greater, then do what? Just do a +1. And now what I need? I can return total. But I again need to ask the question to myself, is this optimal? But it is already greater, so I don't have to do anything. Okay. One more check I need here. If if candy of I is not greater than candy of I plus 1, then only I will do this. Uh, okay. Decreasing, I think we can continue adding one candy. Since we only care about number of candy, I think it can pass. Decreasing subarray, I think we can continue adding one candy. No, I don't think so. If you will keep increasing, then number of candies will increase, and you want minimum. Accumulate. I think it's fine. It's a correct function. Hello. Yep. Okay, my bad. This is, I think, good. Yep, it works. So the logic was is, so you have these two neighbors, okay? So first you satisfy the left neighbors, then you satisfy the right neighbors, and you also make sure this thing you have checked. Because you are not going to reduce the number of candies you're putting over here. Okay. Think about this one. So if I let's just print this difference. Okay. What I want is s- 0. So if there is a path that I can traverse this whole array such that the value, the running sum is not negative, then I can do it. So in this problem, there is a way. I can start from here 3, 3, 6. Then it will become 4, 2, and 0. And be good. Although it is guaranteed that the solution is unique if exist. So if there are some negatives, maybe we have -4 here, and then we have +6. Then it is not possible. Mm, It is guaranteed that the solution is unique. How can I guarantee? I'll start from here. What is this prefix? Still 0. So I don't know, maybe I can do something. Maybe I can do something with the prefix thing, right? Um, let's see. Now what we have? I need prefix and suffix. I can store both if I want to. Right. Right. Um, if there is an answer exist, then prefix minus suffix, it should be something like this 000. Then I can say this is a valid index. Or it can be positive too, but it should not be negative. Wait. I don't know. So this is all maths, induction and all. I can try something else. Largest number. List of non-negative largest number and return it. So like what? 9, then we have 5. Problem is when we have same numbers, we want 34 first. And we can have 3. Convert to string and sort. Yep. Not really. This 3 and 4, they should be together. Right? So not just sorting is not going to work. But constraints are not very tight. So maybe we can do some brute force. In this scenario, I want 3 to come first, not 30. Maybe large, you need to return a string. You have something like let's say 3 and 3 5. Which one you will choose first? Obviously 3 5 3, right? Not 3 3 5. So we need to check for first element. Then if first element is equal, then we should check for second one. We can do sorting of some type, maybe. No. Sort by first digit. If we have 9 5, then we can have 3 3 0 and 3 4. Then I will sort by second digit. So 3 4 comes first. But we have 0 here, right? Um 3 0 is not good because we have something less than 3. Custom comparative, yep. And we can do n square easily. So we can take one number at a time. We can do that. How will I compare between 3 3 0 and 3 4? This is a bit confusing. Like something like 3 3 0 and 3 5. Right? 3 5 should come first because 5 is greater than any of the 3. And then it should be 3 and then it should be 3 0. Numbers can be bigger too. 10 to the power 9. Could be like 8 9 digits, 10 digits. Can I convert all of these numbers into a string? Maybe something like a plus b greater return true. Hmm. I can't think of anything like that. And this is a very famous problem. 1.9 million summation. So it should be easy. I can't think of anything. Um, you can see likes. Do you have premium? YouTube premium? Oh no, I don't. I don't have premium. I don't know. I can also like. No, I don't have premium. Can I separate this? I can try separating these. So 33359. Then we have 04. That's it. So we can get 9 first. Then we can get 5. Then we have 3 and something greater than 3. Something greater than 3 is better. And this number can be greater too. A plus B is 330. Yup. Comparator returns true, of course, after converting all. I don't get it. P30. Let's solve something else. IPO. 3 distinct projects. Design a best way to maximize total capital. After finishing at most K distinct projects. You're given n projects where ith project has a pure profit. Minimum capital and profits. I have W capital in its pure profit. But what do I have? Pure profit and minimum capital. I should have this capital. I want to start this project. And I have this W capital right now. I have to pick K. K should be less than equals to N. No. At most. Okay. Final maximized capital. How will I do it? I'm starting from some capital W. So here we have 0 capital. I can only start with 1. C309 comparator will sort 9330. Then add all and return 9330. But how will you sort like 3 and 30? By summing them up, summing it up like 330 and 303. 303 and 330. Wait. 330 is better. Okay. Okay. So, let's do something. Let's start with yep, you're right. But this is valid for any number, na? So 93 is better or 39 is better? 93 is better. So it was very easy. Why? I did not think of this. Okay. So if I need to I need to convert, but okay, I can do it here, no worries. Okay, converted to string. Now we are going to have 2 points. Okay. And this will not be greater than integer, so it's okay. I can do x plus y, and another one I can do y plus x, x2. Now x1 is from a plus b. So if a plus b is greater, right? So if x1 is greater or equals to x2, then return true. Okay. And now and simply push back. We need to convert to string first. Yep. Oh, okay. I mean, yep. Why I was confused? I mean, this was very easy. Okay, out of range. What? Um, that is it. Also, if I have like 0, we could have like 0, 0, 0, 0, 1. I need to remove zeros, right? Leading zeros from this answer, right? There is a function I can do, but should I store like else do L plus plus? So I can check. No, it's not possible to have zeros. Need largest number, not smallest. Nine to ja 18. Can I use something even better? I can use unsigned long. Can I? But like, okay. Yup, I can. I mean, of course. Oops, here too. My god. What the Where was the error? This was actually very easy. The fuck? No, there we go. No. Largest number. No. Got runtime error. Integer overflow. We have all zeros. Mm, Yep, if first element is 0, return 0. True. I'm getting some error random. This is string, right? Now it's sorting in reverse. Not really. My god. I have never seen like these many errors. Okay. Created a vector of string and I'm pushing back numbers in string form. Then I'm doing sorting. A plus B should, if this is greater than equals to B plus A. So this is correct, right? Can you tell me why? I'm getting 102. So I'm getting 102 and 210. 210 is greater, right? Obviously. What's going on? I have no idea. But why these are already strings now? So like I can do this, but nope. I can ask GPT right at this point. Critical bug. Comparator to follow strict. So this is something I actually don't know. What's a comparator? A strict weakening order. One of the absolute rules of this irreflexivity. It must return false when comparing two equal elements. You know this? You know this? I was not aware. Simply return, yup. But I was not aware of this. Like it should be strict. But like we good. Um I don't know what's going on. Is this so what should I do? I should do this. Very nice. It will have that much exactly. And I have no idea why comparator is not working now. It was working fine when I was converting it into a string. Now it's not working. I can try with the same. Okay. So converting it to the string and then just checking. I don't need this. Here I can check if answer of 0 equals to 0, and I can just return 0. That means every single element is 0. All right. Okay, I think this is going to be accepted. So this was the issue actually, this one. Let's do this one. So first of all, I need to maximize profits, and I want to pick at most K. So and I should have this capital. After finishing your profit of 1 and capital becomes 1. So this profit is going to be the next, or it is just going to be plus capital plus profits. Choose two project units. So this is a bound, right? This is upper bound, W. Now I can pick whatever is lesser than that, and I want to maximize profit. Okay. Okay, let's say I have some capital X. Okay. Some capital X. And I have 3 options. And I wanna pick one, right? Which one will I pick? One with max profit. Is this optimal? And I only want to pick K. Now, after doing that, my X will increase, right? Or decrease, whatever. Now I have this new X. And this new X is going to be optimal. But one thing, do I need to reduce the capital? Profit 1. Either start 1 or 2. At most 2 projects. You need to finish project index 2. Yeah, so you got 1 profit. So this capital is used. Capital is used. This 1 is coming from here. Then being a profit of 1, you have invested 1 and you got a capital of 3. No, so 1 plus 3 is 4. Okay. What should I do? I can use a multiset. I can do sorting. After doing it, maximum. Nope. I can do like maximum capital, maximum profit. My final profit is going to be whatever is the profit. So I have nothing to do with capital. So I should only try to maximize profit. Right. Um okay. If I need a hint, I will let you know. What is time complexity? Hmm. What is K? Uh Number of picks. Maybe I can sort them. Okay. I need to sort it by capital. And for profits, what I can do, I can first start traversing. Okay, until this is equal to or less than W. I'll push this into some max heap. Then I will start popping. And this particular index can only move right. Jonathan Gaming. I don't know that guy, by the way. Profits. Are these both equal? Yeah, no, yep. So let's take an index, okay? Right, so I'm thinking in the right direction. Okay, you made me happy. um so my logic is improving actually. So I want capital of I, and then also profits of I. Okay, then I can simply sort this. Okay, I don't care about profit being minimum max. Now this is sorted. Now let's make a heap. Okay. So I want to start um if I is greater than W, then break. Okay, by the way, I need this. I need to store I. So okay, if V of I dot first is greater than W, then break. Okay, else put this in a priority queue. You had wasted an hour. um Now I know which one I need to pick first. Okay, let's do it. Let's store count. So while count is less than or equals to um less than K, right? Let's start picking. So okay, also I need to keep track of that W. I can increase W. Okay, so this will increase by profit. Now I will start a loop here, starting from so till here I have pushed. I could have used cool. Well, while I is less than N, um same thing. Okay, I have to increase count. Maybe I can do this. Something wrong with Iterator. This is fine, right? This is some vector issue. Sorted with capital and greater than break. Let's keep pushing into priority queue. Pop. Push. What if PQ is empty? Okay. If Q is empty, that means none of them is satisfying. So yeah. Finally. Okay, so learning from this problem. So this was very clear. Capital should be in range. The only thing that clicked in my mind is this thing. Because I'm picking these capitals, profits, W will increase. I can pick more. Okay. Yeah. Array nums return the number of triplets chosen from the array that can make triangles. So what is the condition? Should be greater than, right? And it should be valid for all sides, any one side. So if we have 3 lines and any two of them is greater than the third one, then we can form a triangle. Yeah. I can do n square. Now I can sort that. So let's sort this. 2 plus 2 is how much? It is 4. I want something. So with this 4, what I can, which another number I can pick? I can pick nothing. I can pick 3. So I need something less than 4. How many numbers are less than 4? Excluding this. I can do it. I can use a n square loop and then I can do some binary search. Yeah. The fuck. Okay. So I have picked some I. Let's go and pick a J2. I have picked some I and J combination. Now I should see what else I can pick. Um, can you show the constraint if n square log n will work? Yep. 10 to the power 6, 10 to the power 7, right? 3 into 10 to the power 7. If it's like how much log, it's very less, like 20, even 15 something. 2 to the power, how much is 2 to the power 10? Yep, this is like 10 to the power 7 solution if I will do this. Okay, so now I need to find anything less than that. I will use upper bound. Take 2 number and lower bound. Yeah. Let's get the index. I need to use lower bound because I don't want equal to. So lower bound is sum, right? Then I will get this IDX. I will also remove INJ if less than, by the way. Now we have an index. Okay. So if IDX is less than or equal to I, what? Let's take a variable A. Okay. Same for J. And so if our index is 5, then we have 6 elements. Okay, so count plus equals to idx plus 1. This is number of elements, and then I also need to add this A. So that is it. I think this is good. No. I'm getting 76. Um oh wait. I should not be equal to J. Should I start from I plus 1? Yep. Can't it be idx minus j plus 1? What? I don't get it. What's wrong with the solution? I is not equal to j. Wait, let me think. If I really want to solve this, I can maybe use PBDS. Just go all in. Nah. Two plus two is 4. I did not sort this. I forgot to sort. Okay. This was the problem. Not really. Yeah. This was not a problem though. What is my index? Wait, what could be the issue with this problem? So I can pick ing and I can pick some other number that is less than their sum. So lower bound is going to give me greater than or equal to. Do I want? Wait. What if it's equal to sum? Not valid. I have 2 2 3 4. I'm picking 2 comma 2 coming out to be 4. Then I'm using lower bound on 4. So I'm getting here. I want to do like -1 here. Now I will subtract 2. So there is only one valid combination. I need to fix this thing. I'm getting 2 3 3 3 3. Okay, because so I'm choosing like any combination, but we don't need permutations. We are picking like 2 2 3 and also 2 3 2. This is not something we want to do, so no permutations. What can I do now? We have two numbers. That's a given. And the third number can only start with no. I am using lower bound. That's why. Binary search. Okay. I picked two unique numbers using these two loops. All right. Where I'm going wrong because I'm adding all the permutations. I want to pick unique points. First of all, if array is sorted, then sum of these numbers is always going to be greater than or something. But sum of these two numbers, for example, sum of these two numbers, I only have to look before. Your j will start from 0, not from I plus 1. This thing. Yeah, I mean, between J and IDX. Yeah. J will not start from 0, and the reason is because let's say your I is 2 and J is 3, right? So I have already chosen 2 and 3 this way. Now when your I will be 3, you will start again from 2. So these two positions are going to swap. I don't want that. I want unique. So this 2, 3, 4 is coming from this 2, and this 2 is coming from this 2 actually. So these two are different. Okay. I need to only go till J. Okay. Only till here. But tell me one thing. Sum of any two numbers. This is okay. Also, I don't want equal to, so I don't have to worry about this. What is IDX now? When I'm at 2 comma 2, can I pick anything? This is 4 basically. I need to go from J. How many numbers? There's only one number. When I'm checking with 2 comma 3. No number. 2 comma 4, same shit. Two, three, four is also done. Okay, so I need to pick starting from J to the end. Should be strictly less than. Okay. I don't need this thing. Um, this is wrong. What is this giving me? Am I starting from? Yeah. Be care about +1. Yup, yup, yup. Minus J minus 1. Oh my god, what the fuck? Coming out to be 4. But कैसे? Sum is 4. It should give me this index. So it should give me 2. This is wrong actually. Now I have correct. I'm getting 3012. Okay. Pointer starts from here now. Now this is correct. It's coming out to be 2. Now what I'm adding? This IDX minus J, which is 1 only. Okay. I think it should pass. Okay. This works, but not optimal. Sort. Okay. Some of these two. So these are always going to be lesser than that. I mean, so for 3, 4, there are 2 combinations, right? For 2, 3, there is only 1 combination. Right? So, I mean, 2, 1. 2, 3, 4, 4. There are 4 combinations here. 2, 3, 4, 4. So 4, 4 can pair with 3. Similarly, 3, 4 can pair. 4, 4 can pair with both. 3, 4 can pair with both. This is J. Now J is greater than 0. And if K plus J what is the logic? So one element you have picked, then you're picking another element is I minus 1, J. Then you started looping K. If K plus J greater, okay, variation of threesome problem. Yeah, kind of. So you pick some index, then you pick another one, then you see that there's some. If this is less or like this is greater, then you can add what, j minus k. Interesting. I will check this out later on. Maximum swap. Integer num. You can swap 2 digits at most once to get the maximum valued number. Sort minimum with maximum. Now look at the maximum number. Basically it should be sorted. Then you lexicographically check which part is not sorted and you put that number, and then you return. Swap 2 digits at most once. So there is only one swap possible now. Um, if already sorted, then no swaps. Else we can do something. We can use a stack. So we have 2736. We can do like n square or whatever we want. We can get the maximum. Um, okay. And if this is, if s of I is not equal to m, we will just make a swap and return answer. That is it. Okay. break the loop and convert it into only one swap is possible now. This doesn't work. Don't need it anyway. This is a iterator. So okay. I did not think of this. I should swap with the farthest. Honestly, I can use a map. Can use a map. Comma IDX. Nice. Now I will go from the last. Okay. I will see what this is the current character. If MP of C is already X, is there something is there, then continue else store this index. Okay, maybe wait, can this be like a other way around? So this is less than something, and I need some number that is bigger to be here. So I will get it from the last one now. Right. Is there any other condition? I can also just try swapping and see whatever is maximum. That is also something I can do. Where will I put this? 3. This is correct. Right. Wherever M is. Okay. Fine. Monotone intersection. 2D integer array intervals. Start to end. All the integers from start to end inclusively. Containing set. 1, 2, 3, 4, 5, 6, 7, 8, 9. 2, 3, 4, 8, 9 are containing sets. Containing set is an array nums. Each interval at least 2 integers in nums. What? Each interval start to end has at least 2 integers. So I have 2 and 3. Then I have 3 and 4. Or 3 and 7. Then I have 8 and 9. Okay. So what do I need? What is the intersection of all these points? Okay. It's if not, then the answer is going to be 2n. Okay. 1, 3 and 3, 7. How many points are common? I can take like maximum of their L and minimum of their R. Whatever is that intersection sizes, I will get it. In this case, it's 3, 3. So there is one number that is common between these two, right? Between these two, I can do n square. So but we can do it. What? Are you talking about previous problem? Swap? No, we can only do it once now. Only single swap. A single swap will actually change position of 2 elements now. See, the intersection of these two is 1. There's only 1 point intersecting. So I need at least 3 to create to satisfy till this index. When I move to 8 and 9, I will check how many points are common. And then if there is anything common between previous points, maybe I can extend. 3, 3 has no common, nothing in common, and 8, 9 also has nothing in common. Size was 3. Now it will become 5. That is not reliable. How can I do n square? Till here, what is common? And if every single element have two numbers common, then the answer is 2. If any single element does not have it, then the answer is going to be 4. Single element has only one common, and the answer will increase by 1. So for this element, there's only one element common. These two will be satisfied. Array of size 3. But I only have to check commons. Maybe I can sort them. Are they sorted? Let's sort them. And if one element common between them and one element is common between them, still we can't say one is common between all three, right? Interval can overlap at multiple places. So mm, 3 is common here, so we can use 2, just like use 2 and 3. Here we have two elements common, 2 and 3, so this is good. But here we only have a single element common, so we have to put one extra. I can try to do this. Single element common, we need 2. We need 3. 1, 2, 3. How many elements? There's only one element common. I can't think of anything solid. Any solid strategy that can work. Mm, we split array into some number of chunks. Individually sort each chunk to equal the sorted array. The largest number of chunks we can make to sort the array. So at max it is going to be the size of the array. Then we can extend the chunks. Individually sort. So 5, 4, 3, 3, 2, 1. Hmm. I can do this one. Largest number of chunks we can make to sort. I want one to be here. Okay, so one should be here. So I need to extend this whole chunk. So if I know which element I need here, what is the index of that element? That particular chunk is going to be the one. And one should be here. So we got a chunk. Two should be here. Same chunk. They are fine. They're also fine. 2, 1, 1, 2, 3, and 1, 4. Because they're already sorted. Hmm. So my goal is to reduce the size of the chunk. This is what I want to do. Okay. So what do I need? Are you a college student? Yep. Harshit. Okay. My college is MAIT and I'm in third year. If these two are equal, then they are already sorted, right? It's a 1700 rated problem. That means it is a easy one. If they are already sorted, can I make I can do that. So why I'm not doing it? Okay, let's try. Let's try doing this. And let's move the J pointer. Okay. Wait, what? 1700. I mean, here it is easy. Yep. Look at my rating. It's 2100. Can we concatenate any order after splitting? Yeah, no. We can only sort them. So if over here, if I need one, then I have to extend this till over here. So this is the concept. So what I'm going to do, I can see what my target is. Okay. This is my target. And if these two things are equal, then I can do answer plus plus. Maybe I can do that. Else I will increase the J. Okay. While target is not equal to ARR of I, let's increase this J. Should be less than N. Hmm. After doing that, I will become J plus 1. Okay. And J will be equal to I. And the number of time this loop runs. Let's try. Send it till here, I believe. Then you see here, and this loop is not going to run. So I should be getting something. Completed schooling about this programming domain. Want to pursue BTech in AI/ML. AI/ML, I honestly think the field AI/ML has become very different now. So most of the time it's about using LLMs. Why is it going till here? Something is wrong. What is my, if target is not equal to ARR of I, ARR of J? Yep, you're correct. Wrong answer. I need one here, so okay, but I also need one over here too, right? Told you. What do you mean? I already know that. If the array is descending, answer will be 1. I already know that. Okay, but it is not necessary for it to be descended now. Maybe I have, let's say, 1 here as well. Then what? If I have 41211, oh, answer will be 1. Yup. Is this the only issue? Maybe my solution is wrong. Multiple languages? You can go with Python only. I also did Python. I also did ML. But ML is no longer about training models using, those models, regression, decision trees, random forest, whatever. Now it's all about Gen AI. So basically, web development part, you just have to use some API of some LLM, do your job. So I think now it has changed a bit. Dave, is this like the only edge case I need to think of? No, see, this is not descending, right? And I'll get an answer something like this. If the current number is not sorted compared to next number, then we make chunk of it. Otherwise, we increase. What I'm doing something like this and then this, which is wrong. Absolutely. Otherwise, we increase +1. I do not understand what you're trying to say. The reason I'm practicing greedy problem is I'm actually bad. Okay. What chunks are optimal? I should have 1 right here. But then the correct position of this 4 is somewhere else. So this will be a chunk then. But the correct position of this 1 is 4. This is going to be a chunk. So should I first I need to see what I need here. Then I also need to see where this number will go. Okay, maybe here. And also where this 1 will go here. Maybe here. Um hmm. honestly don't know. Okay, so what I'm thinking is I can do n square. So I will pick this one and I'm gonna compare with everything. Okay. Maybe I can do it. Use a set. I will store all the index that I have pointed. Using this one. Now, if this index exists, then continue. Start checking from I+1. Okay. I need to keep track of intervals. If there are like, and I have already sorted, so only need to check the adjacent. So if there is only one common between them, there is no way that you can have something more common here because I have sorted them. So let's start. I can start merging from here only. But what if I can start checking? I can check with I+1. Okay, maybe. Let's see the common. Right? If then we can break. Okay, that means nothing is common. But maybe those two elements No, it involves some kind of a 2D array. I need to map every single possibility. This maps to 1, this maps to 0. Then I need to see some optimal way. Maybe. How do I do this? Okay, I need to go and eat something. That is obvious. Nope. Okay. So it is just brute force on goal, basically. Now I can easily do it. Not this. I need to check. Okay. I need this part from I2J. I will sort this and I will check with goal whether it is equal or not. Okay. I need original array, maybe. How do I split? Is there like some string way to do it? I can use a loop, but elements from get subarray. Okay. 0 to 2 inclusive. What do I do now? The next element then counted as one valid chunk. Yeah, I have already seen the hint. So I know the solution basically. Now I'm just wasting my time here implementing. Okay. So we know the subarray. Now this subarray, make one like B along with the goal. I can sort this and it should be equal to goal. Right? Oh, okay. Now if A equals to B, this is where we make. Okay, this is a chunk that we get, and I is going to be equal to J plus 1. All right. Get subarray is not valid. Oh, this is a custom function. Okay, I can do it. This is why I said that this is a easy problem. Now I can optimize this probably. This is not good. I can do something. If something is not valid, really, Rohit? I don't think so. 0 millisecond. People have solved it in 0 milliseconds. Oh, can I write such an optimized solution? Zeros J. Start from here. Exactly what I'm doing. Once you found these two are equal, you just make a chunk and make I J plus 1. Um, Max and min. And if at any index right is greater than equal to, I can make a chunk. because so I have max here. Minimum here is 1. Max is not great. I can't make a chunk. Max is 2. Minimum is 1. Um, Max and min. So I can make a chunk here. Okay. But I did not think minimum is greater or equals to. That is not intuitive. Max, min. Oh, I'm comparing with I plus 1. So minimum is 3. That is greater. So if I know maximum number here is something 2. And from here minimum is also, let's say, 2. That means this whole thing is sorted. Okay. Um, More than 8 months. But when I started doing it, I was already comfortable with the scripting and everything, especially maths. So, yeah, this was easy, very easy. Um, Maybe I can solve one of these two. How many problems I solved today? 1, 2, 3, 4, 5, 6. What the fuck? How can I solve this one? Can I just make a 2D matrix and then I can try to be greedy and pick something? I will pick the ones that have 2 or more intersections first. एक साल से ज़्यादा हो गया. I mean, not not that hard. If I can create like a 2D matrix, kind of a adjacency matrix, I can map um, the number of common elements between every single one of them. Then first I will pick whatever greater than equals to 2. I will pick all of them, and I just need to um just two numbers for them. Then I can pick with ones. Nah, this is bullshit. For ones, I need num plus 1, then 0. I only care about the maximum intersection, right? So if this particular element have some intersection, let's say 2 intersection with this one is 1, then I will always merge like these two, right? And I can then merge this one later. No, this one has a single intersection, so I don't know. Can I make a graph? Wait a minute. Can I? What is the bounded? 10 to the power 8. 1, 3. Then we have 3 sub. Then we have 8 and 9. Can I use like sweep line or something? We got 1. So here we are going to have -1 and +1. So So I'm going to have 1. Here it will become 0. Oh my god, so many messages. One point 4 GB. So I have a meet, guys. Okay, so I'll do this probably off stream. I will try to do this one as well. I think I can do this one like 100%. I need to try for more like 15 minutes more. This one I'm not sure because this is very different. Maybe I can do sweep line. So I'll get +1. Then at this index, come on, I will have +1 here too. This is going to be 0. I'll see this afterwards. Okay guys, bye. See ya tomorrow.